Happy second to last Monday of the school year. Isn't that wild? I just can't believe we have like 15, 20 days left with each other. It just blows my mind. But that being said, I know we're all kind of anxious and we get kind of like stir crazy this time of year, but we still need to be focused. We still need to get our job done. We still need to do the things we need to do, especially when I'm not here. So whenever I'm gone, you guys need to be on your best behavior. So when a sub tells you to be quiet, you do so. If they tell you to do this, that, whatever, you listen. So that being said, period 2, no round table. You're going to sit at your desk, take notes, work on your assignment individually today. That's just the way it's going to be today. Period 6, just keep your talking to a minimum. I don't mind if you guys chit chat during work time. However, the work still needs to get done. Okay? It's not a very good feeling when I come and read sub notes that aren't great. It makes you feel terrible. Don't make me feel terrible. I hate feeling terrible. Okay? But that's in the past. We're going to be better today, so new start. Here we go. Today we're going to talk about inscribed angles and how to find their measures. So literally all we're doing today is we're going to give it a picture that looks like one of these 3 circles, and we're either going to be able to find this angle measure here or its arc. It's awesome. We're just building up those big giant circle worksheets I was talking about. It's a good day. Okay? So what is an inscribed angle? Well, an inscribed angle is an angle with its vertex on the circle with 2 sides that are chords. So let's refresh because it's been a minute. Here's my vertex of this angle. Is it on the circle? Yes. So I meet criteria 1. Criteria 2, my 2 sides that are chords. If we review, a chord is a segment that has its endpoints on the edges of the circle. So BC is a chord, as is AC. That is a chord. It has both of its endpoints on the edge of our circle. So, long story short, angle ABC is a inscribed angle. The interceptive arc is the arc that lies between the endpoints of an inscribed angle. So this arc right here, AC, is an intercepted arc because it's the arc that is framed by my 2 endpoints, right? That's my intercepted arc. And there's a really good relationship that exists between our arc and our angle. The degree of the inscribed angle is equal to half the measure of its intercepted arc. So if we pretend that, let's say, AC is, I don't know, 100 degrees, then that would make angle B 50 because it's half as big. So the measure of angle ABC is half the measure of arc AC. So today we're either going to multiply by 2 or divide by 2. It's really that simple. A few other things just to talk about. Intercepting a diameter. For whatever reason, when we get to problems like this, our brains like shut down. We're like, oh crap, I don't know what to do. So let's just look here. It says an inscribed angle intercepts a diameter, then it is a right angle. Well, it should be like a duh moment because if we look here, BC, we all can agree is a diameter because both my endpoints are on the edge of the circle and it goes through the center. So that makes it a diameter. Well, I know a diameter cuts a circle in half, so what is 360 divided by 2? Well, it's 180, so I know that BC is equal to 180 degrees, and we just learned that this angle is half this amount, so half of 180 is 90, hence why it's a right angle. So the measure of angle BAC is 90 degrees. So try not to freak out when you get to examples like this. Just remember it's just a right angle. It's not that bad. And the other weird thing that can happen is when we have overlapping arcs. So if 2 inscribed angles intercept the same arc, then the 2 angles are congruent. And it's easier if you just draw on your paper and see it for yourself because you'll see exactly what's happening. So if I trace out angle ABD, its intercepted arc is AD. And then if I trace an angle ACD, we also see that its intercepted arc is AD. So let's think about this. Let's pretend that this AD had a measure of 90 degrees. Well, then that would make angle ADC 45 and this angle 45. So they would have the exact same measure. They're equal to each other. So if they have matching intercepted arcs, those two angles are congruent. All right, let's get to the fun stuff, like the examples. It says, given the measure, find the measure of angle WXY. WXY is my angle. Its intercepted arc is 62 degrees. And we know that the relationship between its arc and the angle right here that I'm looking for is its half. So 62 divided by 2 equals 31. 31 degrees. Promise, no tricks. It's that easy. It is that easy. Okay, let's see if we can go the other way. This time we're looking for the measure of arc DGF. So let's find it. DGF is this big old arc here. And we can see that its intercepted angle is 113 degrees. So this time we're going to take 113 times 2 and get 226 degrees. Oh. Our next one, find the given measure. So this time we're looking for the measure of angle PQR. PQ to R. This guy right there. It's in your brain. You should be like, it kind of looks like a right angle. Let's just verify that this guy right here is exactly 90. Well, PR is a diameter. It goes through the center of my circle, which makes this arc 180 degrees. 180 divided by 2 does in fact give me 90 degrees. Good work. Good work. Our next one says find the measure of angle RST and RUT. Let's just see here. RST is this angle there. RUT is this angle here. So we should all be thinking, ooh, what do I notice? That they have the same intercepted arc of RT. How are you going to figure out what that is? Don't panic. We have enough information, I promise. So if we go around our circle, I know that this guy is 64, and then this guy gives me 39, and this guy here gives me 75. So I'm only missing the part that I need, but fortunately for us, I know that all the way around the circle has to add to 360. So if we subtract those from 360, we can figure out what those angle measures are. So if I subtract 64, 139, and 75 from 360, I get 82 degrees. I gotta fix this, it's just so messy. All right. So we just found our intercepted arc to be 82 degrees. So now we're working backwards. Remember, this is half that amount, so 82 divided by 2 equals 41. 41. And remember, they have the same intercepted arc, so this angle right here is also 41 degrees. Okay? And one last thing to talk about today, an inscribed quadrilateral. So, remember that's a four-sided figure. It says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, let's review. What supplementary mean? Means they add to 180. If you forgot, put that there. Don't forget it. So in our example here, that would mean angle A and angle C would add to 180. And the same goes for angle B and angle D. Those guys would add to 180. So let's try a few examples with that property right there. Just given the measures Find the measure of angle J and the measure of angle K. So if we look here, we start with angle J. I know angle J. Let's back up a hot minute. Let's first decide, do we agree that this is a quadrilateral inscribed in my circle? Yes, good work. Now opposite angles are supplementary. So that means angle L and angle J equal 180. So for this guy, 180 minus 92 is going to give me 88 degrees. Good job, good job, good job. And the same thing goes for the measure of angle N and angle K. 180 minus 45 is going to give us 135. Beautiful, beautiful, beautiful. And one more just to practice our Algebra 1 skills because those are always needed. It says find the value of x. Oh boy. What are we going to do here? There's a lot going on. So, let's just look at things that we do know how to do. I do indeed have an inscribed quadrilateral, so that's awesome. I really know nothing about angle I and angle G, so that kind of doesn't help me. But we know something about angle J. And since we have a quadrilateral, I know that angle J and H add to 180, so let's just write that down to help us out. Angle J plus angle H equals 180. That will be useful later on. But I know nothing about angle H. Or do I? Or do we? So let's just trace out here angle H. If we look, here's my angle H. Now let's look, guys. Here's its intercepted arc. I can figure out what H is. So let's first figure out what is 96 plus 50. It's 146. 146, right? That's a big arc. And I know angle H is half that amount. So 146 divided by 2 gives me 73. We're in business. We are in business. Because now, if I know that this guy right here is 73 and angle J is equal to this, we're going to plug in, set it equal to 180, and we're good to go. So we will have, do it like here, 12x minus 25 plus 73 equals 180. We add our like terms. I'm going to have 12x plus 48 equals 180. Subtract over my 48, and I'm going to get 12x equal to 132. Dividing out, x equals 11. We did it. Good work. Okay. I would normally do desk problems with you after this lesson because it's fairly short and just because I want to make sure we understand what's going on. So before you start your homework, there should be a Google form link on your classroom thing. Go and do that. I think it's 9 questions, 8 questions. Do that quick for me. I'm going to give you a grade for completing it. Then start your homework. Again, please be good for the sub. I know you guys are awesome kids, and I want them to appreciate you as much as I do, okay? See you tomorrow for sure. I've missed you. Have a great day. Be united. Live the tradition. Onward Central. Bye.